Dimitri Trotignon. Okay, so thanks for being here. You're a chief data officer at BiOceanOr. You're in charge of the development of data products for the software company platform, and you hold a double degree in business analytics and machine learning. And after a first consulting experience at Synomia, where you worked on data strategy, you joined Synthesio, a social intelligence platform, as a machine learning engineer to work on natural language processing problems such as text classification or text clustering. And I think you joined BiOceanOr in February 2020, right?
Yes, exactly.
Okay.
All right. Thank you very much for inviting me. So the goal of the talk today is to uh, try to build a more sustainable aquaculture. That's the goal of BiOceanOr, and how machine learning can help doing that. So maybe you can go to the next slide. The idea of more sustainable aquaculture is important for us, but the fish farmer want to stay competitive. But we believe that competitivity and sustainability are linked. We can take the example of an impoverished ecosystem who won't allow to have a good productivity for a fish farm. And we believe that technology can help farmers to reduce their impact and to have a cleaner and better production. And next slide, please. So at BiOceanOr, we chose one angle, which is the dissolved oxygen rate in water. We believe it's a core issue because problems such as hypoxia can cause fish mortality. The monitoring and the anticipation of dissolved oxygen rate in water can help optimizing the feeding strategy and cut costs. And then the dissolved oxygen rate in water is can be the consequences of other events such as blooms, HABs, harmful algae blooms. We have a great example who happened in Chile a month ago, where a huge bloom killed almost all farm. So next slide, please. But let me introduce quickly BiOceanOr. We are a team of biologists, oceanologists, aquaculture experts, and engineers. The company has been created in 2018, and we're based in Sophia Antipolis in south of France. But we also have sales representation in Bergen in Norway and in San Francisco. Today, our devices are deployed in about 10 countries, in Europe mainly, but also in Chile, soon in Vietnam, in Morocco. Next slide, please. And so how do we work? We provide a solution from the hardware, so the devices to measure the parameters, to the consulting and the help to analyze the data. Our devices can measure up to 15 parameters, such as temperature, salinity, conductivity, pH, dissolved oxygen rate, redox potential, etc. We give a high frequency of one measure every 20 minutes with high precision, and our products are customizable. So if you're in an area with an internet connection, you can have a LoRaWAN connectivity than internet connection. And if you're in an isolated area, you can choose Iridium, which means like satellite connectivity. So we can put our products almost everywhere. And of course, our devices are autonomous in energy. You have a battery, but with a solar panel. Next slide, please. Then the second step is the software part. We provide software to monitor the data from what is collected on the field. And after collecting a lot of data, we saw that we could use all this data, past data, to try to anticipate some events. So we're deploying machine learning models to predict or to anticipate some events such as hypoxia, such as bloom apparition, and we are working on bacteriology for now too. In addition of our internal data, we made some partnerships with companies to add meteorological data, classical, and we recently, 1 year ago, made a partnership with Celes, which is a French satellite operator, providing us satellite data with already run models to have information on a bigger scale. So thanks to our devices, we'll have something really precise on a really located point. But thanks to this satellite data, we will be able to check what is happening around and have more precise models. Next slide, please. So the first goal was the forecasting of the dissolved oxygen. For now, we're providing a 12-hour forecast. The idea, giving an exact prediction was not the idea, because too much parameters would be needed. Parameters we can't have, unfortunately. So we are giving some confidence intervals to be able to catch all the possible values of the oxygen. If we look at the graph, here we have, so the blue line is the real data, the green is the mean forecast, and in red and yellow, you have the max and minimum possibilities. Thanks to that, if we check on the August 8th at 8 in the morning, we see that the dissolved oxygen rate is going below 75%, which is an important thing. So thanks to that, our clients can anticipate and say, okay, we won't feed the fishes at that time because there is not enough oxygen to feed them right now. We will wait 2 or 3 hours. Next slide, please. But while building this dissolved oxygen model, we realized that our sensors, which are in the real world, could face some issues. Next slide, please. The 2 main issues we found are the biofouling, which is organic materials going on the sensor and covering the lens. This biofouling will block the sensor and we won't have any measure, or at least not a good measure. And we also have the sensor drift, or the decalibration. The thing is that as the seawater is a non-controlled environment, with time, the measures are less and less precise. And if you have bad data, you will have bad predictions. So we decided to build a predictive maintenance model. To do so, it was a long work of labeling data, because we collected every data we had and labeled our team of experts, who knows really well our sensors, labeled all the data to say, okay, it's decalibrated or not. Then we train an STM model, and we have been able to detect the decalibration after only 3 data points, which means that after an hour, you can say, okay, your device is decalibrated, so you need to recalibrate it if you want to keep having the prediction. Next slide, please. This thing is important because it haven't been done yet, and a lot of farmers are working with non-calibrated sensors and are basing their decisions on wrong data. Ensuring the data reliability will ensure good monitoring, good decision, and good prediction. And it will save you a lot of time. If you have 1 device, it's okay, but if you have 100 devices on your farm, checking every day if a device is decalibrated or not will take hours. And if you wait only, let's say, 1 month or every 2 months to recalibrate everything, you take the risk of having, for example, 1 or 2 weeks of decalibrated data, which can be bad for your prediction. And then a maintenance done sufficiently quickly will increase the product lifetime, because it's as for everything, if you maintain your product well, it will go longer. Next slide, please. So yeah, I will explain quickly how do we work, so you can keep this slide. As I said, we have an end-to-end solution, so we can provide hardware, software, and support. But we are also adaptable. Like, for example, if you already have your measuring devices, we can plug our software to your data to be able to catch the maximum of people. We are working a lot with fish farmers, but we're also working for institutions such as Monaco government or mairies in the south of France, to help them to monitor the water quality for swimming, for example. Next slide. And just to finish, a quick use case, it was a fish farm in France. Before using our devices, the fish farmer was taking one measure every day. But as we saw, there is a strong seasonality in the dissolved oxygen rate. And the measure was okay, but not always at the same time in the day. And when we deployed our devices, he realized that in some cages where the biomass is more important, there was a huge lack of dissolved oxygen. And the fishes were growing not as fast as in the other cage. Thanks to that, he has been able to balance the biomass between 2 or 3 cages, I don't remember well, and to return to a normal dissolved oxygen rate. Next slide, please. So that's it for me. Do not hesitate if you have some question. I will be happy to answer to it.